This video is on factor label, which is a method of dimensional analysis. So back when I first started teaching and when I first started making slideshows about the factor label method, it wasn't so easy just to get an answer. Like if I wanted 13.9 yards converted into nanometers, it wasn't as easy as it is today. I mean, now you can just type into Google 13.9 yards to nanometers and you will get the following, which was a screenshot from a Google search. And that's great. However, you should know how to do it without Google, how to use conversion factors properly, how to set up a factor chain. And for some of you, I agree. There's really not much reason to know this other than you can't use Google on a standardized test. On the other hand, there are many of you who, in some of your college courses and throughout the careers that you might have, it will be very helpful for you to be able to set up a logical factor chain to convert things. And so that's what this slideshow is all about. So a factor chain is exactly what it sounds like. It's a bunch of factors that are chained together so that you can cancel numerators and denominators out and simplify expressions. So if you had this following expression, you could first cancel the 3's, right? And when I say cancel, it just means that if you have 3 over 3, it equals 1, so you can effectively treat it as 1 over 1. Similarly, you could factor the 2 and the 14, turning that 14 into a 7, and now you have a 7 in the numerator and denominator, so you could factor those out. Now there's a 12 and a 6, you can simplify that to 2 and 1, and the 22 and the 2 and the 11 will factor all out, and ultimately this whole string just equals 1. So the same thing can be done with units or labels. Let's take our original example, which was to convert 13.9 yards into nanometers. So first we start with 13.9 yards, and before we do anything else, we have to figure out a roadmap to get to nanometers. So what we're going to do is set up a factor chain that starts at 13.9 yards and ends up at something nanometers. So we could do the Google method, which takes us directly from yards to nanometers, and if you knew that conversion, that's awesome, but it's unnecessary. You could convert yards to meters if you knew the conversion, and then you could go from meters to nanometers. So if you knew that, say for example, there's 1.1 roughly yards in a meter, you could then go to meters and then go to nanometers. But maybe you don't remember the conversion from yards to meters, and maybe you only remember that there are exactly 2.54 centimeters in 1 inch. The point is, it doesn't matter how complex the chain is. So what we're actually going to do is that last method, and that's because I always remembered there's exactly 2.54 centimeters in an inch, and therefore I didn't bother memorizing any of the other conversions on metric to English lengths there. And so if we do this, what we're going to have to do is figure out a way to convert from yards to feet, then from feet to inches, then inches to centimeters, centimeters to meters, and meters to nanometers. Now yes, we could skip the step from centimeters to meters and meters to nanometers if we want to go directly from centimeters to nanometers. However, in many cases, if you don't want to remember the difference in exponents between nanometers and centimeters, and you're more comfortable recognizing, okay, centimeters is 10 to the negative 2 meters, nanometers is 10 to the negative 9, and if you don't want to go directly, that's fine. Just go to meters as an intermediary. It doesn't matter because it takes like 2 seconds to add that factor. So first let's look at 13.9 yards, and we're going to convert it to feet. So if you look, you'll see that the factor that I set up has yards in the denominator because there's 3 feet for every 1 yard. Now we started with the 13.9 yards, so we always write 13.9 yards to begin, and because without a denominator that's effectively a numerator, the next factor should have the unit that we started with in the denominator. So that's why yards appears in the denominator of the conversion from feet to yards, or yards to feet. So we have 13.9 yards times 3 feet over 1 yard. Well, let's continue on, and you'll see the next factor goes 12 inches in 1 foot. This allows us to cancel feet. Then we go to 2.54 centimeters for every inch, which allows us to cancel inches. then 1 meter for every 100 centimeters, which allows us to cancel centimeters, and then then 10 to the 9 nanometers for every 1 meter, which allows us to cancel meters, and we end up in nanometers, which is what we wanted. So when we factor out the units, like I said, canceling out inches, centimeters, meters, meters, and we're left with nanometers. Now, all you have to do is multiply all of the numerators and then divide all of the denominators. So we get 13.9 times 3 times 12 times 2.54 times 1 times 10 to the 9th divided by 1 divided by 1 divided by 1 divided by 100 divided by 1. Now obviously whenever there's a multiply by 1 or divide by 1, you could skip that step because you're not changing the number. So what I wrote there on that next line where it says equals 13.9 times 3 times 12 times 2.54 times 10 to the 9th divided by 100, I left out all of those ones. And as you can see, I then rounded it to 3 significant figures, so our final answer is 1.27 times 10 to the 10 nanometers. So a note on the significance, we are limited by the 13.9 that we started with. We are not limited by the 3 feet in a yard because that's exact. There are exactly 3 feet in 1 yard, so it's infinitely significant. We are not limited by 12 inches in a foot. Again, that's exact. 12 inches, exactly 12 inches in 1 foot. We are not limited by 2.54 centimeters in an inch. In the late 50s, it was specifically defined as exactly 2.54 centimeters in an inch. So therefore, it's really 2.5400000000, etc. centimeters in 1 inch for the conversion, and therefore it's also infinitely significant. We are not limited by the 1 billion nanometers in 1 meter. The prefix nano means 10 to the negative 9 in case you forgot, and therefore it's also infinitely significant. So in other words, the only thing that determines our significance is our measured value, which was the 13.9 yards. So we have 3 significant figures to start, we have 3 significant figures to end. Okay, let's try a silly one. Convert 154 arbos into farbos. Okay, go ahead, do it. You need this, don't you? Here are our conversions. Okay, great. So now you can see that in order to get from arbos into farbos, we're going to need to go through barbos, carbos, darbos, and ultimately farbos, right? So now this factor chain allows us to cancel out the arbos, then it allows us to cancel out the barbos, then it allows us to cancel out the carbos, then it allows us to cancel out the darbos, and thus we are left with the farbos. So now let's put the numbers in, and you can see if you follow along with the conversions up there, the second factor says there are 2.77 barbos in 13.2 arbos, which is correct. We want to cancel arbos, so we need to have the 13.2 arbos in the denominator with the 2.77 barbos in the numerator. And we can factor out the labels, hence the term factor label. And we are left with farbos. Now we multiply these numbers through, and you will end up with 0.367 farbos. Again, the reason we have 3 significant figures is because we started with 3 significant figures, and in this case, because these are nonsensical words, I used all 3 significant figures in the conversions just to keep it consistent, but there we have it. 0.367 farbos is the final answer using proper factor label method. So that does it for this video on factor label. Feel free to check out some of these other videos on sig figs and scientific notation and rounding, or you can join my channel here, Mental Lancet, and I will see you next time.